All right. A student makes a parallel plate capacitor of capacitance 68 nanofarads, right? Nano, you got to look that up, right? What does nano mean? It's in your little metric prefixes, right? By inserting, this not very much, by the way. Inserting one sheet of plastic film between two sheets of aluminium foil, right? Notice how they spell it, right? That's fun. The aluminium foil and plastic are 450 millimeters wide, right? So that's 450 times 10 to the minus third meters, right? Okay. Plastic film has a thickness of 55 micrometers. Look up what micro is, right? And a permittivity of 2.5, right? Times 10 to the minus 11th, which is, a lot, right? Okay. That's what you're going to use for your epsilon. It's not epsilon naught, but the epsilon, right? Calculate the total length of aluminum foil that the student will require. So you're going to use the capacitance thing, right? This is epsilon, and you'll use this epsilon, right? And then it's going to be area over D, right? So solve that. You know the capacitance is 68 nanofarads, right? We know this thing. We know the, let's see. Oh, there it is. We know the width of this. So wait, we know the distance, right? This is our distance. We know that. And then you're going to solve for the area, right? And then the area is going to be, of course, 0.450 meters, right? Times, or 450 times 10 to the minus third, which is the same thing, right? Times the length that they need, right? And this is what we're trying to find, right? Okay. And you'll get how long this capacitor is, right? So the capacitor is going to be, it's going to be 0.45 meters here, right? And then it's going to be some length there. You're going to figure out that length, which turns out to be shorter than 0.45, right? And then what I forgot to do was multiply by 2, right? Because you're going to have, aluminum foil. You're going to have this plastic sheet, right? And then you're going to have another piece of aluminum foil, right? So you're going to need one for the top, one for the bottom. That's why it's times 2, right? Okay. And then it says the plastic film begins to conduct when the electric field strength in it exceeds 1.5 meganewtons per coulomb, right? So that's times 10 to the 6th newtons per coulomb is what that means, right? Calculate the maximum charge that can be stored on the capacitor, right? So remember that the electric field strength is the voltage divided by that distance, right? They use an R in the data packet, but I like D, right? So the voltage is going to be E times D, and you can figure that out, right? And then, right, so then the distance is this 55 micrometers, right? And you know that that's the, right? So you can figure out what the voltage is that creates that electric field, right? And then, of course, you can find the charge from, charge is going to be C times V, right? And this comes from the definition for a capacitor, right? The capacitance is charge over V, right? So step 1, find that voltage across the capacitor that generates that field. Step 2, figure out the charge on the capacitor with that voltage. You know the capacitance is 68 nanofarads. You know the voltage is something like 82.5, or you'll figure it out, okay?